Great, so welcome guys. We're here to talk about ArcGIS Runtime and building 3D applications with ArcGIS Runtime. My name is Rex Hansen. I'm a product manager for ArcGIS Runtime. I'm joined by Adrien Meriaux, who's our lead dev in 3D in ArcGIS Runtime. He'll be taking us through a lot of demos. I'll be kind of walking us through the slides. So first, just to provide some context. So 3D in ArcGIS is designed to help customers do a variety of things, such as create and manage, and basically quickly and easily extract information out of 2D and 3D data and present that information. But not just present it such that you can visualize and analyze, but also begin to understand some of the change associated with different phenomenon associated with space and time. In addition, a lot of our tools are designed to design and simulate capabilities within the 3D context. And so you're able to maybe better manage your assets and visualize and communicate those changes with your community, your constituents. 3D affects a lot of industries, and so there's many different applications. Whether you're working with visualization of a scientific phenomenon within education, or you're working with environmental assessment, being able to evaluate, plan, and architect different work and planning efforts involved in facilities management or transportation, or working with different defense and intel applications. There's a variety of different capacities in which 3D applies and can be utilized. Now obviously, 3D across the platform is important. We need to be able to, not just to be able to create, manage, and curate three-dimensional data, but being able to host and provide that data effectively to a variety of clients so they can interact with it and publish or create information in a way that can be usable. Now, while it affects or impacts just about every tier within the ArcGIS platform, we're really focused on mobile devices, which also includes laptops or desktops, right? So that's what we're going to be focusing on here. And that means we're going to be focusing on the ArcGIS Runtime. And we consider the ArcGIS Runtime today a modern architecture. 64-bit, it's designed to work with local data, it's designed to work with data in the cloud. Connected, disconnected, it's multi-threaded. We can take advantage of resources and capabilities that are on devices today to enhance the experience that you have with your data. This is notably important when working with 3D. It can be quite intensive, so being able to leverage onboard resources, CPUs and GPUs, being able to leverage the latest rendering pipelines is critical, and that's what we're doing when we're building the Runtime SDK, to be able to take advantage of those capabilities. In addition to that, in addition to the access to resources, we also have a set of common APIs. And so we've built out with the new 100.x release, we've built out a new common API and architecture, a new design, right? And that design is shared amongst all of our Runtime SDKs. So a common experience. Ideally one is not different than the other. Capabilities are shared across all runtimes. So all of our Runtime SDKs, and we have 6, Runtime SDK for .NET, iOS, macOS, Android, Java, and Qt, QML. They're all products built to be able to integrate within developer experiences that are popular today for building native applications. They're all founded on top of a common core, right? This is a common core written in C++, designed to be highly performant and designed to make the most of resources that are available to devices that are running these applications. Now, most of the capabilities that we see and can utilize in all aspects of the runtime, including 3D, most of those are implemented at the core, so that we're able to take advantage of this pervasively across all device types and across all platforms. So 3D in runtime today. Version 100.0 was released at the end of last year, in November. It was the first release where we actually had 3D available in most of our commercial ArcGIS Runtime SDKs. The only SDK we didn't have it in at that time was the Android SDK, and it was still going through a cycle to be able to get some additional functionality. We're going to rectify that here shortly, and we'll cover that towards the end of the session when we talk about the release plan for the future. But functionality that's in the other 5 SDKs will enable you to target every platform: iOS, Android, Windows, Linux, Mac. And the functionality that's available is really founded on different categories or areas within the product. And that includes scenes, layers, 3D symbols, and elevation surface. Now we're going to walk through a couple of these areas. We're going to show demos along the way, just to kind of keep it lively. Actually, it is 8:30, so we'll try and entertain with some of the functionality that's associated with Runtime. We'll be able to see that in action, and Adrien's going to take us through that. But first, just to get an idea of what we expect with 3D. So in general, if something works in 2D, it should work in 3D, right? So if you have something today, if you have a product or an application or a map today that works in 2D, you can take that to 3D, and then you can leverage some additional capabilities associated with that third dimension. So conceptually, within the API, this is a developer conference, so we can talk about some of these classes and components. We have a map view in 2D, we have a scene view in 3D. We have a map in 2D, we have a scene in 3D. After that, things are very similar. You have a set of layers. Now those might be overlays, map or graphic overlays. You might have a set of layers, different layer types. You have the ability to navigate and work with a set of viewpoints or camera positions. And we have a set of symbols that can be unique, that can be represented in 2D, also represented in 3D, but then we have a set of unique 3D symbols as well. So we're going to talk about some of the unique capabilities in addition to what's available in 2D, but available in 3D. So first, just a brief review of what we have with respect to scenes. Right? So the scene view is a control. It's responsible for rendering 3D data. It enables interaction so that you can interact with the content of your scene. It also enables you to overlay that information with other native elements in a scene overlay or graphics, transient information, maybe even session-based operational data with graphics overlays. The scene view contains a scene. So the scene actually defines and contains layers, right? The layers that you want to present in your 3D context. And those are organized and presented by the scene view. There's also a concept of a web scene. And a web scene is really a common specification, a document that's used to define the contents of a scene and how you display or interact with that scene. Dive in a little bit deeper into the scene and its layers and contents that we can actually contain within a scene. A scene layer is a specific type of layer that's designed to host three-dimensional data in a variety of different formats. Now, there's 4 different formats here that we're really looking at. One is 3D objects. Think of these as, like, for example, buildings, multi-patch features. We also include integrated mesh. Think of these as a triangular network of data. Oftentimes both of those are overlaid with textures, such as imagery, to give a more realistic effect. There's also point clouds and also standard geometry, such as points, lines, and polygons. Right now we support 3D objects and integrated mesh within the runtime. In addition, we can take advantage of graphics. So using a graphics overlay, if we have z-values associated with our geometry, we can render those as well and respect those values. Now, this is unique to basically the 3D types of data that you can represent, or 3D content within data that you can represent within a scene. In some APIs, we have KML available, and that's just in beta at this point, right? So we're still working through those issues, but KML is in beta, if available, across any SDK at this stage. So what I'd like to do at this point is dive into a little more detail, and I'm going to hand it off to Adrien. He's going to give us more detail on working with scenes, scene layers, and the specifics associated with scene layer content. So, Adrien?
Thank you, Rex. So, I mentioned that during the plenary, but there's a website on developer.arcgis.com that will explain exactly all the different scene layers that we support part of the platform, and everything you need to know to be able to consume easily, but also produce your own scene layers. We mostly have, as Rex mentioned, few types of scene layers. The first one will be the 3D objects, so you can think of it mostly used to show buildings or inside buildings or direct geometry. We have the integrated mesh, where you take your elevation that can come from your terrain, or it can come also from buildings or vegetations, and you merge that with your imagery. And then we have the point, where basically you take features that could be represented by a point, and then you'll be able to add 3D symbology to it. And a lot of the thinning and all that algorithm is done for you regarding 3D specific use cases, which we don't do with our feature services. And we also have the point clouds, where it's just be able to render millions and millions of points to look like a scene in an efficient way on all our platform. So part of the runtime, we currently only support the 3D object and the integrated mesh, the two first layer, and we're obviously working on supporting the other one for update 2. What I can do is try to show you quickly the difference between these two layers. So I'm running here on my Android device, and I'm going to go to 3D object scene layer. So what's interesting here is to look at the loading pattern. And so you see that the only stuff that is loading is actually, it's super slow compared to my phone. Let me just fix that by making a speed a little bit better.
Someone paid for a visor license, it looks like.
Yeah.
Nice. That's good.
So it's only the buildings that are actually loading. So the different LOD to make sure that it renders quickly, still way slower on the display than it is on my phone. It's really just, the scene layer is just about the building. You can see that the LOD for the building right now doesn't look good, and slowly it's loading better LODs for this particular building. Now, I'm going to try to change speed again. It didn't seem to have worked the first time. Yeah, that's better. Okay, and now I'm going to I'm going to go to an integrated mesh, and you're going to see that the data that's loading is completely different. It's from Meriaux, and you'll see that bam, that whole area is my scene layer. So it's not only the buildings, it's the entire beach, the sea, the elevation, and all the LOD is loading with this type of data. Those are the main difference between a 3D object and an integrated mesh. Back to you, Rex.
Good stuff. Great, thanks, Adrien. Great, so a quick review of really a unique layer type to be able to work with in 3D in the context of the scene layer. The i3s specification is actually a public repo, so feel free to investigate and take a look for yourself. It's a common specification that we're trying to utilize in many different capacities. Next category here is 3D symbology. So symbology that's unique to use within a 3D context. So the ability to be able to take existing graphics and extrude those or extend those to show variations in maybe an intensity or different value. A set of 3D marker symbols that are available to exhibit 3 dimensions associated with points. In this case, spheres, pyramids, square, cubes. Just something simple to be able to utilize a little bit beyond what we provide with a 2-dimensional perspective with regard to point marker symbols. Model marker symbols, so a variety of different model formats, being able to specify, for example, a ship or a plane, actually, and utilize a more representative symbol for the features of phenomenon that you're trying to show within your scene. So a variety of different model marker symbol types that are standard within the industry can be utilized and integrated within and used with your graphics to better represent your data. And then distance composite symbol, this enables you to define a different symbol based upon the distance from the camera. So that as you're far away, you might be looking at a lot of features, maybe you have a lower resolution symbol, and as you zoom in, you can get to a higher resolution symbol. There's obviously a cost associated with more information that you're presenting, so you want to be able to more effectively display your content at the appropriate distance. So with this, I'm going to hand it back over to Adrien, and he's going to take us through some examples of the symbol sets, 3D symbology.
So I'm now running the Java Runtime SDK sample apps that you can actually download from our developer website. And that shows right now the 6 symbols that Rex just talked about, the 3D symbols that are out of the box that you can use right away to put in your scene. Obviously, you can change the size, the colors, and everything you want really easily. But we also have specific symbol, which is a model marker symbol, which means you can take any of your Collada model symbol and just import them and display in your scene. So right now it's a plane, but it can be anything you can think of. Right now it's only represented by a point geometry, so it's usually something that can be placed by a point. But we also, in the future, will have symbol for lines, so you'll have a tube or a wall and that type of things. We also have one specific symbol that is really useful in 3D is the distance composite symbol. So basically here I have my symbol, which is said to be my model symbol of that plane. But if I move the camera a little bit further away from it, it will change to be another symbol. And that is really useful when you're trying to make sure that you could be representing tens of thousands of planes in your scene, but you don't really want to have the model for each of your plane, and then you will not be able to run on low-end devices like phones and things like that. So it's really useful to be able to say, only show the model if the plane is close enough to the camera. Then it actually makes sense to look at the model itself. Back to you, Alex.
There we go. Great. Thanks, Adrien. So trying to keep it lively, interspersed with demos, right? There we go, back and forth. That's good. Great. So a nice review of symbology associated with use in a scene. Next topic is elevation surface. So obviously, in many cases, you want to be able to drape or render elevation within 3D. Very effective, right, for working with different and visualizing different topographical differences. We have a variety of sources that we can use and work with respect to elevation. An ArcGIS image service can be cooked or created in a way that you can expose and then consume. We use a LURC encoded image format to be able to compress and deliver raster tiles that represent elevation effectively. Similarly, we have we can also, in the future, we'll be able to cook that and provide it in a scene layer package, which is really a local file that you can then access this data. We can cook this as a tile package. We can cook this as a tile package and be able to consume that within the runtime here shortly. So you can utilize your elevation data locally. You can also work with local raster data formats. So if you have local DTEDs or other local raster data that's not in a Esri proprietary format, but you can consume and then utilize as elevation sources, that is also supported within runtime today. Now you might also want to leverage multiple sources. And so you want to be able to work with multiple sources at the same time. We support multiple sources at this stage so that you can enable or disable or work with those sources to illustrate different surfaces on which to work or build or render your layers. Now with these elevation surfaces and the elevation surface, you can exaggerate and you can change the magnitude at which those changes within the elevation are represented relatively easily. Just to exaggerate those changes to visualize more effectively changes within topography in areas of interest. Now, each layer within a scene actually has the ability, within a scene or scene view, has the ability to define surface placement. So you can define how the layer is rendered on top of the surface. If you want to drape, right? If you want to represent its elevation based on absolute or relative values. And the graphics elevation mode really enables that with respect to transient data that you're working with that's represented on top of an elevation source or elevation sources. There's also the ability to get elevation data. So if you're looking at being able to query an elevation value for a specific point, that is enabled through the API. We provide it at a variety of different levels. And so if you're looking to work with not just the elevation that's being used to represent your data, but the elevation that underlies, the accurate elevation that underlies that data, we have an API that enables you to gain access to the best elevation values. Now to show this, we're going to flip back to Adrien, and he's going to take us through a nice tour of elevation.
So now I have the Qt sample app that you can also download from our developer website. And here all I have is really three small symbols that are just, one is marked as draped, the other one is absolute, and the last one is relative. So the scene is really simple. It's basically, I'm sorry I cannot make it bigger because it's inside the sample app, but it's basically a base imagery, and that's the mountain. And the surface that Rex just mentioned. That's where your elevation is coming from. And all I had is 3 graphics, and the only difference between those graphics, besides the title, is are they going to be draped to the elevation? So that in that case, we just, don't consider the Z value of that graphic at all, and we'll make it wherever the elevation is. Absolute, where we will represent that graphic as the exact Z value of the graphic. Or relative. In relative mode, we're going to add the value of the altitude underneath the graphic to the Z value of the graphic itself. And those are the 3 different positioning. Things you can do once you have elevation is, for example, you could extrude your graphic and say that I want my graphic to appear, even if it's a 2D graphic, I want it to appear at that particular altitude or relative altitude or absolute altitude. And you can end up with, representing more logical data in a very visual way, that where 3D could be actually really useful. And the last thing I wanted to mention is what Rex talked about is how easy in code to just get the location where you clicked on or anything like that on the map to get the real value of what you clicked on. So it could be a plane in the sky that you just clicked on your screen, and you can get the exact position of where you clicked on by just calling get location on screen function right here. That's
Great.
it.
Good stuff.
UX.
Thanks, Adrien. All right, great. So good review of some of the capabilities of working with elevation and graphics and leveraging elevation surfaces, actually representing graphics on top of that. Next category is cameras and viewpoints. So being able to visualize your data in 3D more effectively. So we have 2 different types here that work together really to provide a perspective, or really a location and then an orientation of your view of your 3D data. And this leverages both a camera, which can specify a location and an orientation of the actual camera itself, and being able to rotate or move that camera around, as well as the viewpoint or the focal point associated with that camera. So these work together so that you can define how you want to visualize your data. There's a couple of convenient methods here that enable you to get the current viewpoint associated with your scene, with your view at this point. And once you have that viewpoint, or if you want to create a new viewpoint that leverages a camera, you can actually assign that or set that on the scene view. This is also shared with the map view, and so we have a very similar experience with the map view and some of these capabilities for defining perspective associated with viewing your data within 3D. And a short code snippet there showing how these might be used in code to be able to get a current viewpoint, change that viewpoint, and then change your perspective. So to show that, Adrien's going to walk us through an example and some code.
Thanks, Rex. So viewpoint is actually a key object in not only the runtime, but across all the platform. It's kind of the link between your 2D environment and your 3D environment. It's all contained into one viewpoint. And that works for the JavaScript API and the runtime, so it's not specific to the runtime. And that's what will be saved inside your web scene or inside your bookmarks and things like that. So what is a viewpoint? A viewpoint has several things. It does have the camera, which obviously is the same for this session, and we're mostly going to talk about the camera itself because the camera is what you use in a 3D environment to position how you look at the scene. And the camera has a location, so X, Y, Z, and it has a heading and pitch. And it will have a role, hopefully at update 2 also. You'll be able to actually hold the camera also. But the viewpoint is more than that. The viewpoint has also what's necessary to define a 2D bookmark. And you can do it by either having a target geometry or by having a target point and scale. And that's how in 2D you can define your bookmark. So the 2D bookmarks will actually work in 3D. So that's why the viewpoint can work in both environments. And a viewpoint will always have at least a 2D bookmark, which means you will at least have a target geometry or a point and a target scale. Always have those. And it might have a camera. So obviously in 3D, all we care about is camera. But if you want to be able to switch between 2D and 3D or pass bookmarks that work in 3D and that will look okay in 2D, what you will pass is a viewpoint. And once again, we'll do the conversion for you between from 2D to 3D, but we will always at least save a 2D position. So if you get a viewpoint from a scene, you will obviously have the camera, but you will also have an approximation of what the scene will look like in 2D, and with an approximation of the target geometry and target scale. So that was for viewpoints, but what we are interested in is just using cameras. So cameras, a bunch of helper methods. So obviously it has, as I say, it has a location, heading, and a pitch, and a role. Right now the role is disabled, but we're planning on being able to enable it in update 2. Quick note about it is when you have a role of the camera, it makes all your interaction really complicated. So that's why we're trying to make sure that right now role is disabled. We're trying to make sure we come up with a design that makes it still comprehensible, that you may have role without add a huge complexity to the whole camera movement. But with the camera, there's a lot of things that you might want to do that are difficult to be able to do it yourself. In 2D, if you want to zoom, you're looking straight down. So basically what you do is just, divide the scale by 2 or, change the altitude by 2. Really simple. In 3D, moving forward, if you're looking tilted at a point, it is hard calculation to get your camera to move forward looking at a point. So we have a lot of helper methods to help you do a lot of calculations that you might want to do to be able to have full control of your camera. So you can move forward, so that will take the direction of what the camera is currently looking at, and will move whatever meters in distance you're telling it to. Or you can move to, instead of moving forward, you want to move the camera towards the specific points. So we have a move toward. We also have a rotate around. You might want to take a point and be able to position your camera at the same distance from that point, but moving around it. And you can also, we have helper method like zoom to and move to, that would just zoom to a specific, move to a specific location. And the camera, something I forgot to mention. I'm talking to mostly developers, I hope, today, but the camera and the viewpoints are what we call immutable. So that means that you have it once and you cannot do anything with it. It's set for good. It makes our API, I think, way cleaner and easier to understand. And also, it allows us internally to do a bunch of improvement and making sure that the camera will not change on us in the middle of an operation. So how you will do it when you want to move the camera? Well, it's super simple. Each of those methods are going to return a new camera. And the benefit of that is that I can decide that maybe I want to start by rotating around a point, and then I define rotating around my point. And then I might be able to say, but no, I want to move toward that point. And you can see how easy it is to basically chain all the commands I want to do, all the manipulation I want to do with my camera. And at the end, it's just going to give me a new camera, and I would have to do is to set it to my scene view. So you can really easily change your transformation and be able to set it to your scene view after. You can set it synchronously, meaning, like I'm doing here, I'm setting my viewpoint camera and it goes straight to that viewpoint. Or you can do it asynchronously by specifying either a speed or a time to reach that point, to have a smooth transition between one bookmark to another.
Good
Back
stuff.
to you, Alex.
Great, thanks, Adrien. So nice programmatic review there of working with both cameras and viewpoints in the 3D context. Again, just to mention again, this is a common philosophy, the use of viewpoints. And so it is having the ability to transition between 2D and 3D within runtime, let alone the concept of viewpoint outside of runtime, within the mapping experience, is relatively pervasive. So it enables you to transition between 2D and 3D quite easily. Fairly common workflow that we find in a variety of different implementations today. So just an example here. That's kind of the end of our technology review with respect to runtime today. But we want to take a look at maybe where does 3D get used today within our application stack at Esri. So we have a couple of different applications that leverage 3D in runtime. ArcGIS Earth, an application that provides a great way for interacting with existing 3D data, 2D data in a three-dimensional capacity. It's free to download, free to use. Drone to Map is another application that leverages runtime in both 2D and 3D. It's designed to be used in the field, gathering information, imagery from drones in the field, and being able to work with that imagery more effectively in both 2D and 3D. Runtime is used for visualization in that application. In addition to that, so use of 3D within applications that Esri builds and then provides to the community. We also provide a variety of different content that you can use and leverage as part of the platform. And so ArcGIS Online provides 3D content that includes 3D layers. So 3D objects that we saw a little bit earlier in this presentation that in most cases represent buildings for cities around the globe. Integrated mesh examples for being able to work with an integrated mesh solution. We have obviously a variety of 2D maps, raster tile based maps that you can leverage and that we leverage within 3D as well. And a world elevation layer that you can take advantage of. That's available as part of online. So these things are available to you. They're available for you to use within 3D. We also work with a variety of different vendors that can generate three-dimensional data in different capacities. And so that's also important as well. We're all leveraging or working with the same specification so that if you decide to work with 3D content for your area of interest, we can work with a variety of partners to be able to generate and deliver that data. Just a note here, so in general, the runtime is not used to create 3D content. We have a set of products that can be used to curate, create, and manage your 3D content. And really three of those are a city engine, which is really think of this as like an industrial strength sort of city content creation software where you can edit and apply rule packages and really leverage a lot of our procedural modeling capabilities, but be able to generate data that then you can utilize within runtime. ArcGIS Pro at this stage really provides a simple editing and viewing or publishing mechanism for your three-dimensional data, whether you're publishing that to ArcGIS Online or Portal, or you're delivering that data to be used locally. So a variety of different package types that can be consumed within runtime directly. Pro is your tool for that. Drone to Map, I mentioned this before. It's built with a visualization that uses runtime, but it's really designed to capture imagery from a drone, right? Generate 3D mesh and orthographic imagery that then can be used elsewhere. If you're looking at modifying your 3D content to a greater extent, there's a variety of other applications in the industry that can be used to build out, let's say, model symbols or build out your geographic information and symbolize or render that information a little bit differently in a more complex fashion. And a few of those are listed here, such as Maya, 3ds Max, or SketchUp. These are more common sort of industry standards for being able to work with three-dimensional content. And oftentimes that can actually then be leveraged within the runtime, right, to enhance the experience that you have. Okay, so now we're going to jump into the road ahead. So ArcGIS Runtime road ahead with respect to 3D. We had our first release in November of last year, 100.0. Our update to 100.0 is coming. Right now it's scheduled for the end of May 2017. So we're looking at about 2.5 months from now. Version, of course, 100.1. One of the critical pieces to this release is being able to make sure that we can support 3D on mobile platforms commercially. And so we're doing a lot of work in trying to make that happen. And it's going to happen, actually, with our Update 1 release, where being able to commercially support 3D on every platform, and this includes adding support with the Android SDK. Right? So we have it in the .NET SDK and the Qt SDK and the iOS SDK today as beta. We want that to come out of beta with update 1 and make that available commercially with update 1. It's not there in the Android SDK, as I mentioned before, but it's going to be available, and it will be commercially available at update 1. There's a variety of things that we're doing there to be able to make sure that we can support mobile platforms commercially with update 1, and that includes being able to improve memory management and resource utilization. So a lot of work is going on there. In addition, we're trying to optimize the experience for the different rendering pipelines that are supported on different operating systems, such as DirectX and OpenGL. So doing a lot of work there to optimize that experience. So a vast majority of the work that's going on, the development effort that's going on is designed to support mobile platforms. But we're also doing a variety of other things to enhance the 3D experience. Another one is being able to make it easier to follow graphics, to follow objects within three-dimensional space, and to have a smooth transition or experience as we're following those graphics and maintaining a perspective within the context of really transient or movable data within 3D. Another option here is being able to support the WGS84 tiling scheme. So right now, the globe within a runtime scene view is only represented to support Web Mercator, but we want to be able to support WGS84. This will enable us to work with tiled layers, whether for raster rendering or for elevation, that are published or available in WGS84 so that we can use those from a developer perspective within runtime. Another level here is something I alluded to before, but being able to create a tile package, ideally with ArcGIS Pro, that contains lurk encoded data for elevation and use that locally, right? Instead of having to work with your own non-proprietary raster data or be connected and work with an elevation service, we'll be able to support local elevation TPKs. Another set of layer types that will support both 2D and 3D include WMS, OpenStreetMap, and web tiled layers, and enabling the ability to work with dynamic attribution. So if there's attribution associated with a service endpoint, being able to render that easily within the scene view. So that really wraps up some of our major features in Update 1, but we are looking at also adding some additional functionality in Update 2. At this stage, Update 2 is scheduled for November of this year, so late this year, and we're looking at being able to support the ability to read and write web scenes. I mentioned web scenes before. Web scene is a common specification, JSON specification for representing 3D content and then sharing that content across the platform, being able to use that within web or native or our desktop applications. What we want to be able to do right now is be able to make use of a web scene much easier so that not only can you read but also write those web scenes and then share that content more effectively. We support most of what's in a web scene today. We just don't have basically we don't have the engine behind the scenes to be able to read and write that without some manual work. We're also looking at supporting client-side labeling. We'll be supporting this in 2D in Update 1, but we'd like to support this in 3D at the end of this year as well. A little more complexity associated with a client-side engine for labeling, so we'll be adding that in as the year goes on. Targeting support for point cloud scene layers, a different type of scene layer that we discussed earlier, being able to support that effectively within runtime. Not only that, but being able to interact with scene layers a little more effectively too, so such as identify and then select and render those selections. And then some additional layer types that we're looking at adding commercial support for across the board, which includes KML, WMS, and shapefiles. And with that, I'm going to pass it to Adrien for a little demo here of our Update 1 functionality.
Thank you, Rex. So the first thing that Rex mentioned is our Update 1 is mostly about being able to run on all the mobile devices. So we already were able to run on the devices because we support a bunch of cross-platform API like Qt or Xamarin. So you are already today able to write apps for iOS and Android. But if you look in the documentation, you'll see that those are actually beta. And it's because it's really hard to take advantage of all the resources you can when you have very small devices like your phone. So we've been spending a lot of effort on being able to detect exactly what the capability of the device is, which means not only which version of OpenGL you're using, but actually go deeper into that. And even if you're an OpenGL 2 device, what type of extension does your device support to try to take advantage of it? And so a lot of memory enhancement that Rex mentioned, and be able to reuse the symbol, the memory used in symbology, for example. If you reuse the same symbol, then we're going to reuse the same memory if your device supports that functionality. So what I have here is basically a simple scene running on my iPad here. And you can really see how smooth it is and how quick it is to refresh. And it's really fun to just play with it. At the end of the session, you can just come and interact with the scene to appreciate the speed of it. One other thing I want to mention is that there's a lot of 3D technology out there. But most of them, when you get close to the ground, they limit your pitch value, because the closer you get to the ground, if you look ahead, you're loading way more data than you are. Right now, we are allowing you to actually have still full control of the camera, no matter where you are. And that's something that we are trying to be able to support in all our devices. So that was running on an iPad, and I showed you earlier, but the same thing running on an Android phone is also, I have the same speed problem of projection. I guess it went back, but it's also really smooth. And once again, you can come here at the end of the session and play with it and interact with it to really appreciate how fast it renders even on small devices. So all our APIs were actually exposing 3D capabilities. Some of them were in beta, but they were all exposing it except once, and that's what I've been using today to show you code is actually Android Studio. So obviously Android was the last one that didn't have 3D capabilities, and we're adding that at update 1, and that's what I've been using today to show you all the code. And so I showed you basically 3D running on iOS, 3D running on Android, 3D running on a Mac. I show you using the Qt API, I show you Java, I show you native iOS for that application, I show you native Android on my phone. We have one API that's missing right now, is the .NET API. And I'm just going to show you quickly what are another new functionality that Rex mentioned, which is be able to follow a graphic. So I'm actually going to be following a plane right now. It's just about a technology that I'm showing now, so it's not the model of the plane. But I'll be able to also look from the plane at the airport, for example. So basically, we have two graphics, one that is used for location and one that is used for targeting of what you want to look at. And you're able to, in a simple API at update 1, be able to control your camera with those two specific geometry. And it could be the same one because you just want to be able to follow the plane. Or it could be alternate. So I'm the plane and I'm looking at the airport. Or I'm the airport and I'm looking at the plane. So it's more control that you have right now with the camera for specific scenarios. And we're trying to render our graphics movement as efficiently as possible, so they all run on different threads. So it's something right now, if you try to do that today, you might have a little bit of jiggering because the graphics is updating on a thread and the camera is on a different thread. So if you try to do that today with the current API, you might have some jiggery of the graphic because those two things are not in sync. So we're going to provide at update 1 an easy API for you to be able to do that, and that is right now showing inside the .NET API. So that's it for what's coming for update 1.
Fantastic. There we go. Cool.
Good to go.
Great. Thanks, Adrien. So a nice rotisserie of different applications and different runtime SDKs. Impressive. Great. So The next topic here is really some R&D work that we're doing, and we'd like to make available at some point here shortly. And this really deals with different ways of working with your 3D data, maybe a little more effectively, sometimes more immersively, right? And this really focuses on virtual reality and augmented reality experiences. Virtual reality, where you're basically teleporting to a different location and you're immersing yourselves within an experience. Augmented reality, where you're really supplementing your physical reality with either virtual objects. Maybe this is on an existing device like a tablet or a phone, or maybe it's more immersive, and this is something we like to call mixed reality. It's obviously a term that's of somewhat debatable term actually in the industry, and there's a lot of overlap actually. So we like to use terms that we can refer to and have a common language on. But you can think of mixed reality as really augmented reality, but a more immersive experience. This is something like a HoloLens device. What I'd like to do is hand this back to Adrien, and he's going to talk a little bit more. Maybe he's actually going to demo some of the work that we're doing and research that we're doing in this field today. Is that right?
Yeah, that's me. That's not in sync now. Thank you, Rex. So what we're trying to do is trying to make it simple to actually go even a step further and try to make, moving 3D to a more immersive experience in a very simple way. So obviously what we need first, because we want to run on VR devices, which are mostly phones and that you put inside Google Cardboard or Samsung Gear VR or Google Dream VR, something like that. Daydreams. So obviously we cannot do anything before we actually run on all the devices. So we are waiting for update 1 and all our improvements to run on mobile devices to be able to take it even a step further and try to support virtual reality and more immersive experience. So for example, I'm just showing exactly the same application I had open earlier, which happens to be my favorite ski resort in France. And one of the cool things about that ski resort is that you look at the highest peak in Europe, which is the Mont Blanc, which what you're looking at ahead of the mount right here. And to take it as a virtual reality experience, sorry, but I think my software keeps on switching my rendering speed, which is not helping. Yeah, that's a good speed, but anyway. So all I have to do is, when I showed on the main stage, be able to use your device's sensor to control the camera. So I'll do exactly this, except that I'm going to add one line of code, which is now I want my rendering to be stereo. And for you, it doesn't look very good, but for me, inside this Google Cardboard, well, I feel like I could go skiing right now, actually.
A very personal experience. Actually, it's nice.
So we're looking at adding that capability to the runtime as a private beta after update 1 and before the end of the year. And if you're interested in VR or AR, for the AR scenario, sorry, I forgot to mention, it's about taking all the data that you're showing and make them transparent and be able to only show one particular layer or whatever you choose to show. And then you can still use your GPS and your device sensor and try to get that experience of only looking maybe through a wall or underground to see features that you already have in your scene. And yeah, by one simple line of code, you'll be able to switch to a stereo rendering mode, or you'll be able to just get rid of everything that is in your background to only see one of your features.
Fantastic.
Back to you, Alex.
Thanks, Adrien. So just to reiterate, we are looking at having a private beta that exhibits functionality that will support VR and AR later this year. If you're interested, let me know. Let's have a conversation. We'll talk about it and see what we can do. That private beta will be after we get update 1 out the door. We need to get some sort of core foundational functionality in the API to be able to support mobile platforms, as I mentioned before, effectively and aesthetically, so that it works well. before we actually start building out VR and AR experiences, oftentimes for these mobile platforms, as we exhibited here. So if you're interested, let me know, and we'll talk. With that, we'll move it to questions. I referenced a couple sites here. One, 3D GIS in general, across the ArcGIS platform and how it's used. It's a great site to go to kind of learn what we're doing, what we're up to with respect to 3D across the platform. And then there's also another site here with Runtime. If you're looking at taking advantage of any of our Runtime SDKs, there's a great landing page here for finding out more information. And with that, we have about 10 minutes for questions. So does anyone have any questions thus far, what you've seen? Any questions for us? Oh, Sud in the back, yes.
I'm going to ask you a question for an imaginary audience. So you guys talked about scene layers that you can display in the scene.
Right.
And there's two definitions of scene layers. One is any layer that I can display in the scene is a scene layer because it's displaying in a scene. The other is it's a specific layer that's optimized for displaying the scene. You guys were using the second definition.
Right.
So this question is about points with the 3D model symbols.
Right.
Adrien said that you do not yet support the point scene layer, which supports the thinning. We understand that, but we're just interested in displaying points with 3D symbols. So could you guys talk about the different ways we could do that? So like the point could be a graphic, or the point could come from a point feature layer. Right? And what are the limitations? How many points can you work with 3D symbols? You also talked about like looking at a target, from a plane, or looking at the plane. But let's say the camera is not moving, but there's a lot of points, and I as a developer want to move the points. What could be done there now and an update one? So if you could just talk a little bit about this area.
Definitely. So right now, if we're working with feature layers, right? So feature layer is the same feature layer type that we're working with in 2D. Today, feature layers are rendered statically, right? And that's for performance at this stage, but that means it's also draped, right? So these aren't being rendered utilizing, they're basically a Z value at this stage. Inevitably, we'd like to be able to render feature layers dynamically, which would give us the ability to work with a third dimension, basically, with feature layers. And that's just a type. Feature layer is a type. So right now it's designed for performance, but there are limitations. It's draped on a surface. If you're working with graphics, and we mentioned this, we kind of alluded to this before, being able to work with graphics is more flexible. We have the ability to render graphics dynamically and represent those graphics through a variety of different means, whether 2D or 3D symbology. The distance composite symbol renderer is actually critical for working with large amounts of data. And so obviously the amount of resources that are required to render content, and that means render complex geometries maybe associated with a symbol, like a model marker symbol for a point, can be extensive depending upon how complex they are. And so there's a certain balance between the amount of information that you want to represent and the complexity of the symbol that you're using to represent it. And so right now, if you're looking to leverage really the third dimension within the context of graphics, you can do that, but there is a sort of a responsibility that you have as a developer to be able to leverage that data and use that data so that your experience is responsive and remains responsive. And so we do offer a variety of different capabilities within the API to take advantage or work with large amounts of data more effectively. Now, of course, there's no hard and fast limits. The API is not limiting you and not saying that you can only render 1,000 features at a time. Actually, within the API, you can only render 1,000,000 features. Right? You have the option to be able to work with as many features as you like, but there's a consequence, right? And that comes back to the responsibility of using your data. Now, what we'd like to be able to do is be able to work with feature layers in a more dynamic fashion, right? So once we have a rendering pipeline that supports the ability to work with feature layers dynamically so that we can render then interact with them, we're also looking at doing is taking advantage of some of the other technology that the platform provides, and this is where a scene layer that offers or presents points, standard geometries, points, lines and polygons, more effectively, right, to the end user, so that we can work with not just scale, but distance, actually from a camera to be able to retrieve the appropriate data for that specific viewpoint, actually. And so that's one thing that the scene layer will provide is the ability to optimize that experience and be able to retrieve data that's necessary at the appropriate resolution based on the perspective of the viewpoint. So Adrien, do you want to add anything to that?
Yeah, I just want to add that there's also some good habits when you're dealing with a huge amount of graphics. So they could come from feature layer that, as Rex explained, they will be draped, so it will not be good to use with the 3D models that you mentioned. But you could just take that feature layer, not displayed, but just take those graphics out and put them into a graphic layer. There's some good habit there too, especially if there are a huge amount of data. We advise to use a renderer with your graphic layer. So try to regroup your graphics by type. So if I have a plane, put them into one plane layer, and then you can use one renderer. That means basically for each of those graphics, I'm going to use that symbol. And for us, it's a huge advantage because, as I mentioned, with Update 1, we're really trying to dive deep inside the devices and make sure that they could support instancing, and that's key in that example. Instancing is be able to pass one symbol to the graphic card, that's my boat symbol, and just reuse it for all the graphics that you have in your map. So it's really key to have a good programming habit of trying to use renderers to make sure that the same symbol could be applied everywhere. Yeah, there's no hard limit because it depends on your device, depending on how you program things. But we have solutions to be able to support huge amount of moving graphics in 3D, even if we don't support the point cloud or the point layer yet.
Great, thanks. I think there are a lot of people who are very interested in that. I think actually articulating that out would be very valuable. So this pattern that you talked about, where you just, the set of points that I have, I can just read them from the feature layer. I don't need to dynamically keep going back to that feature layer as the camera is moving around. Let's just say in one snapshot, I'm going to read them all. Then I'm going to create graphics out of them.
Right.
And then there's guidelines for how I create those graphics that you were explaining, right? To do with the complexity of the symbol versus using a simple symbol. If I do use complex symbols, peeling it apart into different layers and using instancing like you were talking about, I think the more that we can share about those patterns with people, the more useful it will be, because there's a lot of applications out there to be written.
Right. I agree.
Thanks.
Yeah, it's a good point. Thanks, Ed. Thank you. Any other questions, guys? Great, good deal. Thanks for joining us this morning. And if you have any questions or you'd like to talk about our private beta coming up, feel free to come up. Thanks again, guys. Have a great rest of the conference.
Thank you.